Good evening, everyone. A warm welcome to all the participants to day 2 of our faculty development program. I hope you all enjoyed and learned a lot from yesterday's session. Today, we are happy to continue our learning journey with another expert talk. It gives me a great pleasure to introduce our distinguished resource person for the day, Dr. R. Manjula Devi, ME PhD, who serves as the head of IQAC and professor in the Department of Computer Science and Engineering at KPR Institute of Engineering and Technology, Coimbatore. Dr. Manjula Devi has over 19 years of teaching and research experience. Her areas of expertise include machine learning, deep learning, data science, and optimization techniques. She has authored more than 100 research papers, including over 50 index journals, and has written 25 plus academic books and lab manuals. She has guided 8 PhD scholars, received several prestigious awards, including the Dr. APJ Abdul Kalam Award for Teaching Excellence, and delivered more than 150 sessions as a resource person across reputed institutions. Her dedication to education, research, and academic quality truly makes her an inspiring to all of us. Now, with great respect and enthusiasm, I hand over the session to Dr. Manjula Devi ma'am to share her valuable knowledge with us. Over to Manjula ma'am.
Thank you so much for your wonderful introduction.
Thank you, ma'am.
Good evening, all present here. First of all, I like to thank Guru Nanak Institute of Technology Management and HoD-IQAC for giving me this wonderful opportunity, as well as Anisha ma'am for continuously tracking me to start this. Thank you so much for your hospitality and everything, ma'am. So before I started, so this is my topic, from data to insight, unlocking hidden patterns into knowledge. So this is the today's session that I'm going to take it. So before I started, I like to introduce myself. Myself, Dr. R. Manjula Devi. I am working as professor in computer science and engineering, as well as leading the head of IQAC, KPR Institute of Engineering and Technology, Coimbatore. So instead of having the PPT, I like to share directly with the Google Colab so that I'll give the hands-on session to you. That my screen is visible, ma'am?
Yes, ma'am.
Yes. So for today's class, I have taken the data set as iris data set. So using the iris data set, so I'm going to have in-depth knowledge how you are going to analysis the data from the data sets. That means how each and every analysis will reflect the data, how we are going to extract the knowledge and how the data is distributed inside it. So this is the way that we are going to look into it. So for this, I have taken the sample data as iris data. Okay, so here, so for this, since we are going to use many pandas, so we are going to imported the pandas as PD. So you can able to import the data in 3 ways. One, CSV format. So where you can able to attach my CSV file here. So that you can able to upload my CSV file. So this is my already, I have downloaded the CSV file here. So I have taken it. I'm using open means my CSV file will get uploaded. So what is the meaning of this warning means? So whenever this screen is closed, so the file that is uploaded will be deleted. So if you want to have this file, whenever you are opening this notepad, you have to upload the CSV file. So it will not be permanently available here. So otherwise, you have to access the data from the Google Drive. So this is the CSV where you can upload it. So here for demo purpose, I have directly taken data from the website itself. So this is the web page I have taken, where I have attached it in IECS UCA repository and the ML machine learning databases iris.data. So if you take this, when you open this one, so you can able to get the data, iris data. So this is the iris data. So I can able to get it. So this is the location where we have taken the data. So second, for this data, since you're not having any column name for this, totally how means first, since it is a CSV file, CSV file stands for comma separated values. That means each and every column is separated by comma. So this is the first column separated by comma, the third column. So second column, then third, then fourth, followed by the classes. So since there is no column name, we are defining the column name for us. First column, it is chapel length, it is centimeter, then sepal width, then petal length and petal width. The last column is the class. So this is the column name. We are going to use it further for all the process. How we are going to retrieve the data from URL means already URL has been furnished. Since it is a CSV file, so you're going to use PD. PD is nothing but the object as the pandas dot read CSV. So you are using URL. That means the data where we have extracted, and then what name you are going to do means whatever the column name that we have extracted here. Suppose here instead of URL, if you are going to use the CSV that we have uploaded means, so this is the one. Instead of this URL, you have to furnish the CSV file. So this is the content that we have to show it off. So second, we are going to display the head. Head and tail means top 5, top 10. So this is the first 5 samples or 5 10 samples, so that we have to check whether it has been properly uploaded or not. If you want to view the last 5 or last 10 means you have to use tail. Second, if you want to filter among this content, if you want the specific data to be filtered, for example, say instead of 5 columns, we need only 2 with class. 3 columns means classes, chapel length and chapel width means 3 column means you can able to filter the data. So here the data that we have read, I have stored in the iris underscore data. Okay, so this is the data frame that we are going to use it. So if we are going to filter these 3 columns, under this we are going to display the head. So here if you want to short it, this filtered data, because this is the iris data, if you want to short it means short underscore value. In which column? Because we are having 3 columns. So under which column if we want to filter means based on this column, chapel length in centimeter. Based on this column, we are going to short it and we are going to sort it in the ascending order. So we are going to display this in the sorted order head. So here we have, so the pandas has been imported, the package has been imported. So we are going to display this. So here this is the column we have displayed in the ascending order of the chapel length in decimeter. So here this is a chapel length in centimeter. So this is value 4.3, 4.4, 4.5. So it is the ascending value. The remaining thing will be shuffled because based on this column only we have arranged it. So this we have displayed the top 5. So head. So this is the way where you can able to filter or where you can able to assign the sort the data. So if you want to display the first 10, head means the default value, it will display the first 5. Just the tail means last 5. If you want to display other than that 5 means you have to mention how many rows you needed to display it. So head 10 means the top 10 rows will get displayed. So tail means top 5. If you want to have a top 10 means you can go ahead. Second thing, if you want to know how many rows and columns of this data set means shape will give the number of rows and columns. So this is the last 5 rows and this is 150 samples and 5 columns. Okay, so that is the meaning of it. Shape means row. First value represents row, second value represents columns. So 150 rows and 5 columns, that is the meaning of it. So next one is we are going to display the information. So what does the information will represent means? So here totally how many columns and width means totally 0, sepal length, width, length, petal width. So here how many non-null count is there? Null count. Is there any, is your data set contains null data set or not? So if it is means how many non-null means without null values. So that is the meaning. So as our data set totally how many data samples are there? 150 data samples are there. Out of 150 data samples, in each and every column, chapel length 150 not null. That means there is no null value. That is the meaning of it. So chapel width also 150. There is no null value. Each and every column there is no null value here. So that is they reflecting here. Okay. So this is the way we have to check. We are going to check whether there is any null values in the data sets or not. If the null value is there, we have to go for the replacing that value either with the missing technique or any technique, mean values or average. There are a lot of missing techniques are there. Yeah. So you can able to apply this to replace the null value. So that is the first case. Second case, this next we are going to look into the describe. Okay. So describe is nothing but iris describe it will give the summary statistic. Okay. So next summary statistic, and each and every statistic we have given the they have produced this near 6 decimal values after the decimals. Yeah. If you want to round it to 3 or 2 means based on your requirement, you can go for describe dot round of 3. So that is the meaning. Round off 3 means it will round off to 3 decimal values. So before we look into it, what this each and every summary represents. Okay. As per this summary, it will give the value for all the columns here. Okay. So here chapel length, chapel width, petal length and petal width. So here what are the components it gives? Count, mean value, standard deviation, minimum, then 25 degrees, 25 percentage, and then 50 percentage and 70 percentage. So what is this count will represents means, so total number of data values present for that particular features. So for as per the chapel length and chapel width, petal width concerned, count is 150. Okay. So for each and everything, there are total number of data points under that particular feature is 150 values. Second, it comes to the mean values. Okay, mean value for represents the average central value. That is the meaning of it. Okay, central value for the particular columns. For example, for mean value for the sepal length is 5.84 and here it is 3.05. Third one is 3.75. Then it is 1.119. So that is the mean value. That is the central value. That means what is the average chapel width for all this? Okay. Uh, for example, here we are saying this is chapel length value is 5.84. So 5.84 is the average sepal length, then 3.05 for sepal width. So here mean value is 3.76. So this is the average value, that is a mean value. Next comes to the standard deviation means, so here how widely the data is spread alone. Okay, whether all the data is near to the close value or it is far away or equally distributed. The range of the value has been equally distributed or not. So that is the meaning of it. So here for this value, it is 0.83. Okay, 0.83 means, so here the data that is distributed is moderate. So that is the meaning. 0.4 means it is less variance. Okay. Third one is 1.76. It is totally, it is the variations is very high. Okay. That means what is the variance means? The value will be very nearer. When it is small variation means the difference between the values is very less. So that means the values that is distributed between the each and every column is not far away. For example, if my pass mark is all the students who have got values from 60 to 70 means, so it is less variance. All the students 70 class are there means if the value for the subject you got 60 to 70 means, so it is less variance. When it is from 50 to 80 means okay. When your data is from 0 to 100 means it is the high variation. That means the all 70 students, the mark has been distributed across, the range distribution is very high. So that is the standard deviation. So the third one is 1.76. It is a high variation. Then 0.76 means slight variation. So when compared to the standard variation, chapel length and petal width value is, they have slight variation between, whereas chapel width have the values of the chapel width is have the slot variations. So that is the meaning of it. So when you go into the values, so when you display the values, we'll display and see. So what we have said means, so it is a slight variation. Which one is slight variation means petal chapel width. Yeah. So when you say chapel width value, see here, listen the values. So it is 3.5, 3.0, 3.2, 3.1, 3.6. So the values between the each and every rows is slightly variated. So that is the chapel width. So whereas the chapel length variation is what we have given its chapel length variation is, it is highly, and we go for petal length. It is 1.76. Petal length means the value. See here, it is 1.4. The same time the value has is from 5.1. Maximum all the values from 1.4 to 5. Whereas when you look into the values of chapel width, it is only between within the three values. Whereas in chapel length and petal length, from 5.1 to 6 values it is there. It is 0 length. It is still 2.3. So you can able to see the values that is distributed under each and every column that reflects under the standard deviation. 1.7 means the difference, the data that is distributed across is widely spread. Okay. Whereas when it goes the value 0 to, that means 0 means nearer to 0 all, it is slightly small difference between the values. When it goes high value means the difference between the values are very high. So that is the meaning of it. So what is the minimum value means? Minimum value of each and every value is 4.3. So when I say it is a chapel length, it is 4.3. And then for a chapel width, it is 2.2. And then petal length, it is 1. And then this one is this one is 0.10. So this is your minimum value. Maximum value is 7, 4, 6.90 and 2.5. So this is the minimum and the maximum values. When you say these are the minimum and maximum value. When you say it is a 20%, 50%, 50%, 70% means is nothing but a quartiles they are represents. What does mean by quartiles? Okay. Now I have to know, okay, what is the range of the values? What is the difference? Okay, in which range of the values my values are? So if you want to say that is, so 25% of the chapel length is 5.1. What is the meaning of that means? Total 150 values are there. Out of 150 values that in the chapel length, okay, 25% of values are less than 5.1. That is the meaning of it. Okay. So under the chapel length, totally you are having 150 columns. Okay. 150 rows. Out of 150 rows, 25% of floors have the chapel length less than 5.1 meaning. Next one is 50% means, so it is a median chapel length. So, okay, 5.8 means half the values are below 5.8 and half above 5.8 centimeter. So what is the 70% means? 70% of floors have the chapel length is 6.4 centimeters. So there is the range. How many percentage of the values have this range? So that is the meaning of it, quartiles. Okay, from this say that I can able to say that my chapel length are between from 5 to 6.5 centimeters. So that is the meaning of it. When you say this distribution, most of my chapel length values are lies from 5 to 6.5 centimeter. So that is the meaning they are saying it. When you come to the chapel width, my 50%, the 25% are 2 and 50% are 3 and 75% of 3, 3.3. So the variation is 2.8 to 2.5 something to 3. So this is the variations. Okay. So this is the way your describe functions work. So clear what is the meaning of this describe? Okay. Now shall we look into the next one is how to find the null values and how to find is there any unique values are there, and if you find any unique value means if we want, that means if you have any null value means we can't able to process it. Okay, if the value is null you have to replace it. Second, if all the entire row is null means I have to able to process it, I have to reset it. And if there is white space, because when you take the column name, if there is any trailing and back or white space are there, I have to remove it. Otherwise, it will not be, some process error will be there. See, if that is the case, how will you do it? So that is the first step. So for this, what I have taken means instead of creating none values, okay, again the data, I should not disturb the data set. So for this, I have created just with the same name. So 5 rows are there. So 1, 2, 3, 4, 5 columns are there. So that means 5 rows we have created it. Okay. So we have created a none value as the last one. That means my first row is 5.1, 3.5, 1.4, 0.2. Iris itaso is the first sample. Second sample is 4.9, 3, 1.4, 0.2. Iris itaso. Third row is 6.2, 3.4, 5.4, 2.3. Iris vernica. 5.9, 3.0, 5.1, 1.8, iris versicolor. Then last row, all the values are none. So just we have created for demo purpose. So just it is the sample. We have displayed this iris data 1 and we are checking for before I started. So this is my data set. So 5 samples are there. Okay, totally 4 samples which contain, the last contains the null value. Okay, so first row what we have checked means we have displayed the data. Okay, then we are going to check whether how many null values or missing values are there. That means under this iris data, we are going to check how many null values is null. Then if it is null means how many values. Sum means we are going to sum how many null values are there. Okay. So second, how we are going to display the unique values. Once it is done, we are going to drop the values. If any null values are there, okay, NaN means it is how, if all the values are none means it will drop it. So once it is dropped, okay, so because 150 samples are there, if 150 samples, if some are values are not null, then null means if you are going to delete it means the index may get vary. Okay, so if you don't want to disturb the index value means it should be a continuous means. So we have to go for reset index, drop true. Okay, when the data is dropped, the index value will not be a random. Again, it will align sequentially. Even if the rows is getting deleted, the sequence index value will be aligned sequentially. Suppose if 1, 2, 3, 4, 5 are there, if the fourth is getting deleted means, so 1, 2, 3, 5 instead of this, okay, it will align again with the 1, 2, 3, 4. So that is, it will reset the index. Second thing, this is if there is trailing or trailing or leading spaces are there, it will remove it. So once it is removed, what is the shape? We are going to link to it. As per this, we are having one row is not a null. It will remove the last row and display it. So as per this missing null value sum, so each and every column must have one null values. So under chapel length, one not a null, under chapel width, one not a null, and petal length, and then petal width. So this each and every value contain null values. So that is this thing. So before cleaning, my shape is 150 comma 6. After cleaning, my shape is this one. So here 0 it has been reduced to this. After cleaning, I have written as data 1. So one second, it is one dot shape. So before cleaning, okay, the shape of the iris is 5 comma 5. It is not 150 comma 5 because we have created the samples here for demo purpose, because we don't want to disturb the entire data set. For further process, just we have created the data set under iris dot. So totally 5 and last column is null. So totally how many null values are under each and every column, it will display the null values. So if there is any null values, you have to take it into process. Okay, before cleaning it is 5 comma 5. If you want to remove it means you can reduce it to 4 rows. Okay, so 5 columns. So this is the data sets after removed it. So this is the way we are cleaning it. Second, if you want to check any duplicate values, null means null values are there. Okay, if there is any missing value means it will be taken as a null value. If the missing value has to be replaced from, many techniques are there. Okay, how to handle the missing data. So you have to apply the technique and you have to go ahead. Second, if you want to check whether the duplicate data, if there is any duplicate data means instead of learning the again and again, so better remove it, the system will learn more. So if not to check whether is there any duplicate data or not means, this is the step iris underscore data set duplicated. Okay, check whether there is any duplicate values are there under that, means it will count it. How many duplicates values are there? So it is displaying the number of duplicate values is 3. But you can ask question, okay? Under the data set, there are huge data set are there, 150 samples are there. If you want to find in which, that means what are the rows is under the duplicated values. So it doesn't know, okay, what are the samples are duplicated means. So you can able to display the duplicated values. So here, duplicated iris, that means I have to find what are the duplicated index and what are the samples are there. Okay, so here iris data set, okay, under duplicated, you are going to retrieve the index value. So iris underscore data set duplicated will retrieve the duplicated values. If you want to sum means it will return the number of duplicated values. If you want to display the dot index means it will display the index value. Okay, so this is the index. So these are the indexes of that. Okay, so duplicated indexes converted into the list, it will display the what are the duplicated index value of the duplicated rows. Now, if you want to locate, okay, so with value means here iris data under this. So these are the index. So that index value will get displayed. Now, as per this, index of duplicated value is 34, 37, 150 rows. So these 3 rows are duplicated. 34, 37 and 142. Okay. Now you can able to display it. So these are the values 34, 37, 142. So these values are duplicated values. So you can able to take it. Now I have to duplicate. Now if you want to remove this duplicate, now you have identified how many duplicate values are there and what are the index, what are the duplicated index rows, and you have displayed the values also. Now if you want to remove this, okay, 3 duplicated values are there in your data set. So here iris data drop duplicate. I already said if the values are dropped, some value index may get varied. Okay, so you can able to reset the index so that these numbers will get assigned to some other data samples. So this is the iris data clean. Okay. Now if you want to remove the duplicate means, so this is I just remove, we are displaying the shape before and after it. So before removing it, it is 150 comma 6. After removing it is 147.6. So already 3 samples has been removed. So before removing it is 150 comma 6 and after removing it is 147 comma 6. So this is the way. Now these are the numerical values I have taken. This is iris data underscore clean. So that means after cleaning, we have taken it and we have displayed it. And we have used that values for thing what are the mean value and what are the this one median value, and what are the mode values, so that you can able to distribute the distributions. And I already said these are the highly distributed. Variance means the variation between the values in the particular columns, so that it reflects it. So these are the variance under that value. Now here we are going to give the outlier detection. Outlier detection means how many outliers are there. That means as per the quartile is concerned, we will be fixing the range of the values. So that values are the okay, good, because most of the data are lies within that range. So that is the meaning of outliers. Okay. Now we have to find how many layers. Many outliers are lies means if there is any values which is deviated, okay, most deviated from out of this range means I can able to say that as an outlier. So here for this, for each and every columns, we are going to take it. So the cleaned data as per the column, we are going to take it a quartile 25% and then quartile 75%. Already it is IQR is nothing but interquartile rate. That means we have to separate, we have to minus the quartile 3 with quartile 1. So quartile 3 means 75%. I already from this description we have taken it 25%, 50% and 75%. Yeah. So that's 75. I think you can get it to describe. So describe that is 25%, 50% and the 75%. So from this, we can take it this value, that is the 75. This is the quartile, this is 75 quartile and the 25. When you subtract this two values, you will get IQR value. So that is they are saying it here. So this is the quartile. 0.25 is 25% and 0.75. This is quad 1, quad 2. I have subtracted this value of Q3 minus Q1, all the values. Okay. So here we are taking as a lower and the upper. Lower value is Q1 minus 1.5 into IQR value. Okay. Then Q3 plus 1.5 into IQR. So this is the lower and the upper. When you're going for box plot, you can able to use this quartile for it. So forthcoming thing, we have given the box plot. This is used for the box plot. Okay. Second thing, outlier is what are which outlier we are taking. It means when the value is each and every column, when it is less than lower and this is upper than, this is the value which is less than lower value and the value which is less than the upper values. So the range between lower and upper are the correct one. When it is lies outside this means, so it is, they are treating it as an outlier. Okay. Outlier means the which is false samples, it is not belongs to the particular thing. Okay. Outlier. So we can able to detect it. So when it comes to the point sepal length in centimeters, so total the Q3 and Q1 is 3.15 to 8.35. This is the range. Here none of the values are lies less than 3.15 or above 8.35. When it comes to the sepal width, okay, so 2.05 and 4.05. So this is the range. So how many outliers are there above less than 2.05 and above 4.05 means 4 outliers are there. Okay, when you go to the box block, you can look into it. Whereas the petal length, this Q1 is minus 3.6 and the Q3 is 10.35. So there is no outliers. Whereas in a petal width, my outliers is minus 1.95 and then upper Q3 is 4.05. Okay, so how many outliers are outside this range means there is no outliers. Among this, chapel width have 4 outlier value. That means 4 samples or lies outside this range. So that is the meaning. The values that lies outside this range, they will consider this as an outlier. So this outlier constraint means, that means your learning will get deviated. So you can able to remove or you can able to adjust the values so that it will be within the ranges. That means outlier reduction. How to handle the outlier reduction? You can able to apply the technique over here for this. Okay. Next comes to the number of class distribution, how the class is getting distributed. Because when you are going for this, we have to go for balanced data set. If your machine want to learn deep means the data set should be a balance. How to identify that my data set is a balanced or not? That means the number of samples under each and every classes should be equal or it is closely equal to each other. So that I can able to say that the classes are balanced each other. But if it is not balanced means, then I can say the data set is an imbalanced data set. If it is imbalanced data set means the data which have more samples, the machine will learn will get more knowledge about the data. The data which contains less samples, the system will not learn much about that particular class. So this is the way. So in order to avoid this, if you want the machine to learn, okay, equally of all the samples means the data sets with present the data samples for under particular each and every classes should be equally distributed. Now how to identify it? So this is the way how to guide this. So under this column, what is the values count? So from this it says that versicolor is 50 and then as per the cleaning, because I'll display the original data value, iris data. Once again. Once I read data is play. Why the iris? Just I'll display here and check it is there any problem, because as per the value count is there, it should display 50. But it is showing because iris clean, we have removed 3 datas. So here some data, iris data has been updated somewhere. It will take time to monitor it. So here, as per this value count, each and every classes, iris citaso is 50, versicolor is 50, virginica is 50. That means all the samples which can, all the classes which contains 50 samples equally, I can able to say it is a fully balanced data set. Okay, so that is the meaning of it. But here I have used iris data clean because as per the clean, how many data are there? Before cleaning 150, but after cleaning it is 147.6. 3 samples has been deleted. So among this data set, this is the one. So IC vesicular is 50, Virginica is 49. That means out of 3 samples, one belongs to Virginica and then Citaso is 48. But totally 147 samples are there. Okay, some iris data set has been modified before that, so I'll look into it. But anyhow, so this is the class distribution. Now if we want to group it, okay, so how many mean values are there, how much it means, so here that is, so iris clean, I am going group by the values with number of columns, mean value rounded to 2. So this will summarize this clearly. That means it will, this is a citaso. When you say it is a citaso, the mean value of the mean value, sorry, the mean values of the column chapel length for the particular class iris citaso is 5.0. That means the only the mean value of this iris citaso class, mean value of versicolor, the mean value of virginica's color. So that is the values. So that is how much it is getting displayed it. Now we are going to go for the picture normalization, how the value is getting normalized. So this is the normalized value. So here how we are going for min-max normalization. Okay. So here min-max scalars, we are going to normalize the iris clean based on the number of columns, and just I have displayed it. Among this is scaled values. So here this is the as per this class is concerned, we have displayed the head first 5. When you see the values, so before that I am printing both the values so that you can able to get the datas before cleaning, after cleaning. So after normalization. So when you say this before normalization, my values is 5.1, 4.9, 4.7, 4.6, 5.0. That means I have displayed only top 5. So head layer. So chapel length 3.5 to 3.6. Petal length is 1.2, 1.4. Width is 0.2. This is already equal. Okay, just top 5. But after normalization, if you look into it, I can able to say the values from 0 to 1. Min max normalization, the min value will be a 0 and maximum value is a 1. So based on that value distribution, it will go for a min value. Okay, min max scalar normalization, min max normalization. So the values will be from 0 to 1. So when you look into it, all the values from 0 to 1. So that is the meaning of min max scalar, min max, minimum maximum normalization. Next comes to the unique classes. So when you say that the name of the class is unique means, so here it is the unique. So what are the unique values content means iris, itaso, versicolor and virginica. Here this is the class distribution values 50, 50, 50. So you can able to plot it. When I gave the histogram means how the values of the histograms are there. So this is the histogram values. When you look into it, so here the values of the values of sepal length in centimeters, you can say that the sepal length will have the 5 value. 5 has the frequency of 25. That means from this histogram, what you can able to get means how the values are distributed under water range. So as per the sepal length scale, 5.5 value has contains many samples. That means near 25 samples contains the values 5. That is the meaning. So totally 4 samples has contained the value 7.5. Okay, so here when you say that the range of nearly 22 samples which contains the range from 5.5 to 6, that is the meaning of it. So when you scale this 4.5 range means totally 5 samples are 5 samples contains the value 4.5. So this is the values, and this is how many samples contains this value. When you say sepal width, so here more than 35 samples contains the values 3 to something 3.1. It contains 3.1. 3.2 or 3.3 values, the around 30 samples contains 3 to 3.2 or 3.3, and then around 2.6 or 7 this values contains 25 samples are there, remaining and all out of this range. And equate for petal length, the values doesn't have the row samples in the petal length have lies between 2 to 3. All the values are less than 2, or some values are less than 5 to less than 3. None of the samples contains the value from 2 to 3. So that is the meaning of it. From this histogram, I can able to say that none of the samples has the value from 2 to 3. Next comes, so here none of the values from 0.6 or 7 to 0.8 or something. The remaining, well, the highest values lies from 0.0 to 0.2. That means 0.1 and 2, I think so. So the values, nearly 35 samples are having that values. Okay, so that is no values from 0.7 to 0.8. Okay, so that none of the samples between lies from 0.7 to 0.8. Okay. When it goes to the box plot, I already said as per the quadruples contained. So this is my Q3 and Q1 values. So Q3, see this Q1 and this is Q3. So the values that lies from this above and this, it will be taken as the outlier. So here, this is my outlier of this. Already said sepal width contains 4 outliers. So this 4 outliers has been directed. The values below this value and the value above this has been directed as 1. So this is the maximum and minimum values. Okay. So this is the maximum of the values are lies between this one. So that is the, they are saying it as the range. Out of this values they have been written. Already I said the 4 outliers are for sepal width. So this is the box plot. So I can able to find the outliers. For remaining thing, there is no outliers. So if you want to find the outliers, box plot can be used for it. Box plot is specifically used for finding the outlier, for detecting the outlier in the given data set. Next, get for scatter plot. From the name itself, I can able to say how the values are scattered with each others, how it is getting related with each others. So that is the meaning of it. We have plotted this between chapel length and chapel width, and petal length and petal width, and then chapel length and the petal length. So we have plotted between these pairs, these 3 pairs. So here I have given it, this is the way. Sepal length and the petal width. How the values are distributed with dependent with each others, how they are related with each others. Okay, is there any patterns can be decided it? So that is the they can able to say. When you say this is the values are here somewhat correlated and this is correlated with each others, when the value is getting increased, that value is also getting increased. Is there you can able to say that it's a linear proportion or non-linear? So I have to say. So when you say this totally cluster each others. So these 2 values are here and some values are clustered here. And when you say this is, they are most of the thing they are linearly increasing. When the values of chapel is getting increased, petal length is also getting increased. I can able to say the linear increase of the these 2 parameters. So this is the scatter plot, how the values is. Next, here the scatter plot, I can't able to differentiate the classes. So I can able to find the, even if you related with each other, but I can't able to say which samples belongs to which class. There are some mild changes only there. If you want to know the colors, with colors means I can go for class colored scatter plot. So based on the class, we have given the colors. So this is the way. So same for each and everything, we have sepal length with sepal width. So this is 3 colors they have saved it. So I can able to identify that. So these are the 3 different variations. I can able to say the correlation with 3 different colors. Next comes to the correlation matrix. Correlation matrix means how they are correlated with each others. Okay, when you say that iris data CORR, only numerical only true means only with respect to the numerical values alone. non-numerical values will not be taken for correlation. So that is the meaning of it. Okay. So when it is near to 0 means they are not, when it is less than means they are less correlated, when it is greater than means one near to 1 means they are highly correlated with each other. So that is the meaning of correlation. When I say that sepal length is strongly correlated with sepal length, so all the diagonal values will be 1. So here sepal length, width, and then petal length, and then petal width. So the diagonal values, because same features is strongly correlated with same one. When I say it is minus means, what is the meaning of it? Mean sepal width is less correlated with sepal length. When I say it is 0.8 means sepal length is somewhat strongly correlated with sepal length. Sepal width is strongly correlated with sepal length. So that means if the value, how it is correlated means if the value is getting increased, that values will be getting. That means if you are making changes with something with one parameters, automatically the alternate parameters getting deferred. That means the value is getting, so it means when you say this is sepal length with petal length with petal sepal length means if you are increasing this value will get increased. Otherwise, if the value is getting increased, if you are saying it is a decreased value means it will get decreased. If you change the values in one features, if it affects the another feature means then it is strongly correlated. If it is lessly affected means it is lessly correlated. That is how the values is getting dependent on each others. That is the correlation matrix. When you say it is a heat map, they have differentiated it. So same values only, same matrix they have given in the pictorial form. So what is the meaning of it? Means 1 high correlation each others, and then this last one is minus 0.5 less correlate. The through colors we are going to differentiate it. So 1 means strongly correlated. When you say sepal length and sepal length are strongly correlated, width and width are strongly correlated, petal length and petal length are strongly correlated, width and width are strongly correlated. Other than this diagonal, you can say these values are strongly correlated. Petal width and petal length. Petal width and petal length. When you say petal width and petal length, here, when you look into the value, it is 0.963. That means it is nearer to 1. You can say it is a strongly correlated. When it is strongly correlated means I can able to get the color near to yellow. That means as per this slide colors, okay. So one is given with the yellow. So the very near yellow is given with this one. Okay. Next comes to the 0.872. That means petal length with sepal length. So this is petal length with sepal length. So somewhat light greenish. Okay. So light greenish, it nearer to yellow. So that is when you say it is low correlated, when you say sepal length and sepal width, sepal length and sepal width. So here dark blue. When I say this purple is the very, very low color, that means sepal width and petal length. Sepal width, petal length. So here minus 4.21. Okay, and then sepal length and sepal length and petal width. So these two. So this is 4.02. So that is very low, lessly correlated. It is worst. Okay, these values are doesn't depends upon each other. There is no relationship between these two values. So that is the meaning. They are less correlated with each others. Okay, highly correlated means if you change values means automatically the opposite features will get changed. Okay, so that is they are highly correlated with each others. Less if correlated each other means if you do anything, it doesn't affect the value of alternate means I can say that it is lessly slightly correlated. That is the meaning of it means. So I can able to say from this you can say which are the inference features we can take it and which is less, and I can able to reduce the values of it. So that is the meaning of it. Just for demonstration purpose, I have changed the values of iris data in the data sets. Just I have displayed it, but at present for demo purpose, I have created the values and I have shown to you. So this is what are the columns are available under. If you want to print the columns, print it. So if you want to extract the values from this range to this range means 10 to 21. So you can able to take it. If you want to store that sliced value and you can able to store it in the value and you can able to print it. I already said if you want to go for filter the data means I can able to specify the column name and you can able to printer it. If you want to count the number of columns and you can think. Then if you want to go by some mean, median for each and every columns, you can go ahead, and the group also you can go ahead with this. Next comes to the scatter matrix. Okay, so this is the pairwise. So how we are going to plot it? So iris data, numeric columns, alpha 0.7, histogram. Diagonal values, you are using histogram. For other thing, we are going to use scatter matrix. Okay, so that is, they are saying it. So here, fixed size is 10, 10. So that is the value you are saying it. So here, we are using histogram for the same class and the scatter plot for the remaining. So for chapel length, width, petal length and petal width, you are using scatter. So I can able to say how from the diagram itself we can say which one is linearly proportional. So here when you look into this diagram, so I can say that petal length with petal width, I can say they are correlated, because when you increase the values means automatically when you increase the values of petal width, the petal length will get increased. So that is this strongly correlated. When you say petal width and length, we'll go for the correlation between that, how they are correlated with each other's. Where is correlation? Petal length and petal width. Petal length, petal width and petal length. So I can say how much value it is? 0.963. Upper, when the value is getting changed with 1, automatically the other value is getting. So when you change the scatter plot, you can able to observe that they are in the linear. That means when the value of this linear, this is x-axis is petal width, y-axis is petal length. When the value petal width value is getting increased, automatically petal length is getting increased. So I can say that the values will affect it. Here also petal length and the petal width. So here this also somewhat, but here and all I can't able to say that my petal length when the chapel width is increased, I can't declare that chapel length will get increased. So I can't able to make it. Now here in somewhat, some portion it will get increased, but some portion it may not increase. So it is lessly correlated. These are the, no, it is, there is no maximum, it has minor correlation only. This is also having minor correlation. This is also having minor correlation. When you say this is a correlated means I can say chapel length with petal length, chapel length and petal length. We now will say the correlation matrix of this chapel length and then petal length. So I can say it's 0.73, 0.872. Okay. So when you say that chapel length and width, it is minus 0.109. Chapel length and chapel width, if you give this scattered part, chapel length and chapel width. So I can able to say it is a lessly correlated. Okay. So from the diagram itself, we can say whether they are lessly correlated or highly correlated, and you relate this scatter plot with the correlation matrix. So that is, they are saying it. So same thing we are using for this one, colored one with pairwise relationship between the features. So I can say able to say same colors, but with respect to the colors, classes. Okay, so now from this, what you can say, I mean, they are highly correlated each others. Okay, so I can able to say this is belongs to Citaso, versicolor and Virginica. So from with respect to colors, you can go ahead with this. Okay, what is the range of the values and which colors has a range? So for when you take this, so the which color Versica values lies from this range to this range, whereas Citaso the values of this apple length is from this range to this range. I can able to predict it. Whereas here these three Versica and Citaso have same values. Virginica and Citaso lies away from here. These are equal. They are far away from the value. The distribution is not near to each other. Whereas here the values are getting somewhat variance. So if you say this, we can say that the variance, how the values are close each others. I can say able to say that sepal width variance is less. I think I look into the variance of this. Describe. When you look into the describe, where is the describe? Count, info, describe, standard deviation is here 0.433. That means chapel width distribution, because then I can say petal length it is 1.76. Okay. Then this one is standard deviation is 0.76. Okay, these three are okay. And this is totally data is getting distributed. This is somewhere less. Okay, so based on this, we can able to say, I can able to, from the diagram itself, I can say how the data is getting distributed. So here, all the data are very near within the same range. So there is no distributed. I can say this is a standard deviation. That means the spreading of data within the particular column is very small. They are very close to each other. Whereas here, somewhat here. When you say this is, so here, one class is here, another class is here, the overlap of this is very less. When there is overlap of the classes very less, means automatically standard deviation is away. When the overlap is more, means automatically standard deviation is very less. So here also. So this is the way your data is getting distributed. It means how the values is getting distributed among the x-axis. Next comes to the outlier check using the Z score. From the thing, I can able to say that 15th, roll number 15 is having the outlier rows, number of rows is 1 and that row is 15th row. I can able to say that reprint row is totally deviated from the Z score value is 3. So it is, you can able to remove it off. That also belongs to Cyrus, Iris, Itaso classes, which is very far away from this. So I can able to remove it off. That is the based on the Z score values, we are declaring how to identify the outliers and how to get it. Okay, here I have said that sketch score value is 3. The values which is less than 3, we are saying it is an outlier, and that 15th row is having outlier values greater than C. It has been taken off. Here I can able to use any number of rows with the values. So this is also a correlation matrix with heat map. The one is highly correlated and the blue color is less correlated. Already said. Okay, sepal length and petal length is very less correlated compared to sepal length and petal length is more. That means highly less correlated with each other. Okay, so that is the meaning of it. So you can able to use the colors also. Here, cool, warm, and what map is you want? Cool, warm, and then autumn. Autumn is there. Next comes to the how to apply the logistic regressions and how to predict the values. And this is my box plot, how we are using the box plot, bar chart. I can able to use bar chart for how the value is getting distributed. So these are the quartiles. I already said these are the outliers. So this is my total values, minimum and maximum, upper, low, say in IQR, we have find it out the lower and upper. This is lower and this is upper. This is 25% and 50% and 75%. So this is my thing. This is Q and Q tar and this is lower and upper. The values above and below will be considered as an outlier here. So that is, they are saying it. So here, which are the features is very important. When you are going for the feature selection, I can able to conclude that petal length is having high. So I can able to take the petal length is important and then petal width, then comes to the. So if you want to take the values based on the 0.2 above means only 2 features. When you say 0.1 means 0.3 features, I can able to take it off. So this is the way, and here this importance, how important it is. So how you can able to perform the feature selections. So that is sepal length is least important and then sepal length, petal length is highly important to each others. So how we are going for the deduction based on how the feature is getting selected, we have given it importance of the features. Importance means how to select the top 2, top 1. So that is, they are saying it here, how to select the importance of that particular features. So using the random forest. Next, how we are going for detecting it means, so this is the logical regression for detecting it. We have find it out the standard min max and we are fitting it and we are finding PCA for reducing the components. We have taken to reduce it to 2 components, PC1 and PC2. Based on PC1, PC2 only, 2 components we have taken it. Okay, so that 2 components we have taken for process. So as per the variance, it is 2 variants, 0.72 and 0.23, and we have taken for that one. And we can taken as this one, PCA for a thing, and then a logistic regression for with the iteration of 200, and we have taken it off. And then we have drawn the confusion matrix also. This NS is not defined. Where is so we have didn't draw it. So confusion matrix. So 19, 13, 13, we have taken it off. Accuracy is 100% because there is no other data members or lies outside it. So this is my confusion matrix that has been got for the particular classification. So we have taken only 2 features. Okay. So totally 4 columns are there. As per the PCA is concerned, we have taken 2 columns. For the 2 columns, we have applied the logistic regression and we have got the confusion matrix. So this is the way you will be classifying it. So any doubt? We have any doubt regarding this? So I have come. So up to the knowledge that I know that I have applied for my research, up to my knowledge, I have delivered everything. Okay. If you have any doubt, you can clarify me.
No, ma'am, you explained everything in your presentation, ma'am.
Okay, ma'am. So participants, if you have any doubt, you can ask. And also, if you have any doubt or anything with respect to research, you can approach me during any time. Uh, this is
Okay, ma'am. Thank you so much
okay, ma'am.
for such an interesting and informative session. We truly gained a lot of insight from your talk. I also thank all the participants for your active participation and attention throughout the session. With this, we come to the end of the day 2 of our FDP. We will meet again tomorrow for the next session. Thank you all and have a great day. Thank you so
Okay.
much for your valuable session, ma'am.
Okay, ma'am. Thank you, Anisha, ma'am.